This lesson is section 1-5, Personal Expenses. And our quote is, if you want to understand today, you have to search yesterday. So if you want to understand today, you have to search yesterday. Now, this is true for basically anything to do with finances. If you want to understand how you're spending your finances, you have to look at the history, okay? The objectives for this lesson are going to be to graph bivariant data, to interpret patterns and trends based on data, to construct a scatter plot, to fit a linear regression equation to a scatter plot, determine the linear regression equation, find and interpret the correlation coefficient, and make predictions based on lines of best fit. So we've got a number of key terms here that we want to understand and know the definition of for this particular section. The first term is scatter plot. This is a graph, first of all, okay, that shows the relationship of bivariant data using points on the coordinate plane. So it's a graph of points. It's not a graph of a line and such. Now, bivariant data is a data set where each element is an ordered pair of numbers, okay? You've got an X and you've got a Y. Correlation is an association between two variables. So we're looking at how two variables are related. Causal relationship is a relationship where one variable causes a change in another variable, okay? Next is linear regression analysis. This describes a situation in which the equation of a line is found that best fits the points on a scatter plot, okay? A linear regression equation is an equation of a line found using linear regression analysis. So using linear regression analysis, we find a line that best fits, and then that equation is the linear regression equation. Independent variable is the variable that can take on any permissible value, okay? It does not depend on the values of another variable. A dependent variable, however, is a variable whose value is determined by the value of the independent variable. And lastly, correlation coefficient, represented by R in most cases. It's a number between -1 and 1 that is used to judge the relationship between two variables. The closer to +1 or -1, the stronger the relationship. So we're going to look in this section and see how can we predict trends and how can you use that information. So here's our first example. Ravi is a 16-year-old high school student, has a part-time job after school. He is looking to see if there are any trends that relate monthly income to monthly clothing purchases among his high school peers. He thinks these two variables might be related and wants to investigate them using a scatter plot. Below is a list of ordered pairs where X represents the monthly income and Y represents the monthly clothing expenses for 10 of his classmates. Construct the scatter plot by entering the data into a graphing calculator or using a graphing software to create a digital scatter plot. So I used a graphing utility called Desmos, and I plotted the points, and this is what we get. Notice the vertical axis is clothing expense, and the horizontal axis is monthly income. So you can see the various points we've got. Now notice, as we're increasing our monthly income, the clothing expenses is going up. So this indicates a positive correlation, or in other words, a way of looking at it is a positive slope. So let's look at example 2. For many people, the cost of contact lenses is a discretionary expense, okay? It's not something that is mandatory. Jamil buys contact lenses through an online retailer. He has found the type he needs is sold 6 lenses to a box. The retailer has a sliding price based on the number of boxes purchased according to the following table. Notice the top row is boxes from 1 to 24, and then the bottom row is price per lens, okay? Now, examine the scatter plot created using the bivariant data in the table where the x value represents the number of boxes, so the top row is going to be x, and the y value represents the price per lens for that, so the second row is going to be the y. So if we plot that data, we get something that looks like this. Notice the vertical axis is price per lens, the horizontal axis is number of boxes, okay? Now, what do you notice about the number of boxes purchased and the price per lens? Well, as the number of boxes increases as we're going to the right, look what happens to the purchase price. It starts going down. So this is represented by a negative correlation. Another way of looking at it is it's negative slope. It's going down. All right, now let's go back to the data from example 1. Now they want us to find the linear regression equation, or line of best fit, for Ravi's scatter plot in example 1. Round the slope and y-intercept to the nearest hundredth. All right, I would suggest at this point you check out the video on using Desmos to get linear regression. There is another video on the topics page which explains how we do this, okay? But if we take these points and we do the linear regression analysis, we come out with this for an equation. Now, the 0.29, that's the slope, all right? And the minus 22.02, that's the y-intercept, okay? And as I say, that you can get these using Desmos, and it's explained very nicely in that additional video on the topics page. So now, using that same information, I want to interpret the slope, okay, as a rate for Ravi's linear regression equation. Remember that slope is defined as rise over run, or y over x. So therefore the slope in this example is dollars spent over dollars of income. Well, now, again, we want to continue with that same set of data, and Ravi wants to determine an appropriate monthly amount to budget for his own clothing based on the analysis of the data in example 1. He works 2 part-time jobs and gets a small allowance from his parents. His total income is $420 per month. So what is a reasonable amount for his clothing expense? Well, first of all, we go back to the linear regression equation that we came up with, which was 0.29x minus 22.02. We're going to plug in 420 for x. And if I do that, I come out with y equals 99.78. Or in other words, a reasonable amount that Ravi should spend on clothes is $99.78 per month based on his income. All right, now, again, using the same data, we want to determine the correlation coefficient to the nearest hundredth for the relationship in Ravi's data. And then we want to interpret that. Well, as part of doing the linear regression analysis on Desmos, it tells you what R is equal to when it comes up with the best fit line. And it tells us that R is equal to 0.98. So as I said, this is obtained from the linear regression on Desmos. Again, if you look at that video, it'll explain exactly how you come up with this value. Now, because 0.98 is positive and greater than 0.75, in fact, it's very close to +1, we know that there is a strong correlation between the monthly income and the amount spent on clothing.